Hey everyone, and welcome. We hear all the time about these amazing things AI can do, but we don't really talk about what it actually takes to build it. So today, we're going to go behind the curtain and look at the heavy-duty, essential infrastructure that makes it all possible. Because, to really get AI, you have to get how it's built.
So let's just ask it straight up. How is great AI really made? Is it some flash of genius in a lab, some magical algorithm that just pops into existence? Well, the reality is way more structured, and honestly, a lot more interesting. It's less about some kind of magic, and way more about solid engineering.
That's right. The absolute best way to wrap your head around how innovative AI gets created is to imagine it's being built in a super high-tech factory. And in this explainer, we're going to build that factory from the ground up, piece by piece, just to see what it really takes.
Okay, first things first. Every factory needs power. You gotta keep the lights on. But our AI factory, well, it doesn't just plug into a standard outlet. Nope, it needs a special kind of power grid, one that can handle these massive, almost unbelievable computational demands. This is the fuel for our AI ambitions. Think of it like this. In our factory, you've got two kinds of power. Standard CPUs, those are like the office lights and the computers at the reception desk. They're essential for the day-to-day stuff. But the real work, the heavy lifting of deep learning, that requires industrial-grade machinery. And that's where GPUs and TPUs come in. They're the giant presses and robotic arms built for one thing: massive parallel computation. So, this power grid has to be smart, right? First, it needs what we call elastic computing. That basically means you can crank up the power for a huge job and then dial it way back down when you're done, kind of like a factory adding an extra shift for a big order. Second, you need dedicated sandboxes. These are safe, isolated R&D labs where your teams can experiment and break things without messing up the main production line. And finally, usage monitoring. This is your electricity meter on steroids, keeping a close eye on costs so your big ideas don't accidentally bankrupt the company.
And what's the payoff for all this? Well, it's right here. When you get the power grid right, you create a stable, scalable environment. And this isn't just some boring technical detail, it's the foundation, the concrete slab that allows powerful, reliable AI models to be built without, constant blackouts or system failures. Okay, so the lights are on, the heavy machinery is humming. What's next? Well, our factory works with some of the most valuable raw materials on the planet: data. And just like a real factory dealing with gold or diamonds, that data and our finished products, the models, they need to be protected in a top-tier, Fort Knox-level secure vault.
Now, building this vault isn't just about one big lock. It's a process with a bunch of layers. First, you build the walls, isolating your work in secure environments. Think of them as self-contained labs. Second, you hire the guards, controlling access with really strict identity checks so only the right people get the keys. Third, you lock the doors by securing the network with firewalls and encryption. Fourth, you install cameras by logging and monitoring every single action, creating a perfect audit trail. And finally, you set up an inventory system using data catalogs so you know exactly what you have and where it is.
So let's peek inside this vault. It's got to have huge, scalable storage. We're talking massive data lakes or cloud systems like S3 and Azure Blob. It also needs automated backups, which are kind of like a fire suppression system in case anything ever goes wrong. And this is crucial. It needs clear data retention policies. These are the rules for how long you keep your materials and when you have to securely get rid of them.
So, the point is, a properly built vault is so much more than just a set of locks. It creates a system that's resilient, super well organized, and secure, protecting your assets while still making them safely available to the right people. This is really how you build a trustworthy operation from the inside out.
All right, power is on, our data is secure. It's time to head to the assembly line. This is the factory floor. This is where teams of data scientists and engineers come together using all these specialized tools to actually build the AI models. This is where it gets really cool.
The absolute heart of any modern factory assembly line is the master blueprint. And in our AI factory, that blueprint is a tool called Git. It's a version control system that tracks every single change made to the code and the models. If an engineer tweaks even a tiny little component, that change is logged and everyone can see it. It makes sure the whole team is always working from the latest, correct design.
Next up, quality control. You can't just build stuff without checking it, right? That's where tools like MLflow come in. Think of it as the QC log for the whole factory. Every experiment, every tiny tweak to a model, every training run, it's all meticulously recorded. What settings were used? What were the results? This log stops teams from repeating the same mistakes over and over and gives them a clear, data-driven path to making things better.
And finally, to make sure everything is consistent, every single worker gets a standardized toolkit. This is what containers do. They package up all the software, all the libraries, all the dependencies, so every developer has the exact same environment to work in. This completely gets rid of that classic, well, it works on my machine problem. It makes the work truly reproducible.
So what do you get when you have a well-organized assembly line like this? It's pretty clear. You get teams that can collaborate with incredible efficiency. Every step is transparent, every result can be reproduced, and you can trace every single decision right back to its source. It just works.
Okay, our factory is running like a well-oiled machine, but there is one last, absolutely crucial piece. A factory can't just do whatever it wants. It has to operate legally and ethically. It needs to follow the official rulebook for building AI that is trustworthy and compliant.
This is how abstract laws become concrete factory rules. You take a big privacy law like GDPR, and it translates into a simple rule on the factory floor. Handle all customer data with extreme care and never use it without permission. A responsible AI framework becomes a mandatory step. Every model has to be tested for fairness and bias before it can ship. You see, it makes compliance just part of the everyday workflow.
And you know, following the rulebook is a full-time job. It means doing regular security assessments. Think of them like fire drills for your data. It means constantly reviewing your security policies and bringing in new governance guidelines to keep up with a world that's always changing. It's a non-stop process of being vigilant.
At the end of the day, the result of all this work is an AI factory that doesn't just make cool stuff, but does it in a way that's secure, compliant, and responsible. And this isn't just about avoiding fines, it's about earning and keeping the trust of your users and society as a whole.
So let's bring it all home. We often think the secret to some breakthrough AI is one single magical algorithm. But as we've just seen, the real secret is the infrastructure. It's the power grid, the secure vault, the collaborative assembly line, and the official rulebook. The supposedly boring stuff is actually what enables the brilliant stuff. The secret is the well-built factory.
So, we've laid out the complete blueprint. The foundation is set, the machinery is in place, and the rules are clear. Your factory is ready to go. The only question left is, what are you going to create with it?